where we're going next. So, this is a fun one to chit-chat about. We're going to fuse up some statistics today. So far we've been talking mostly about, what math class would you place the topics we've studied so far into? Grade and similar triangles. What math classes, if you had to pick like a math class that you would put those topics into? Blake, what do you got? Algebra 2? Awesome. Awesome. Math 105. Well said. I was thinking more like traditional like algebra 2, algebra, geometry, calculus, that kind of thing. What math class? Math 105. So algebra 2 for both of them, Blake? Yeah, for sure. Other ones? Anybody say geometry? Maybe.
Geometry and a little bit of trig.
Geometry and a teeny bit of trig. I did sneak some damn trig on you, didn't I, with the tangents? Tangents of the angle. That was definitely a little bastard move. But since you guys can solve But since you guys can solve proportions so well now, it's just a matter of substituting out a value you pull off of a table and solving an equation. Yay! It's pretty straightforward. So you got a little bit of trig, very nice. You got some geometry, some similar triangles, some algebra 2. Awesome. Totally awesome. Totally awesome. And that's not going away. I still want to bring the idea of being able to solve minuscule equations as we need them. I also want to tie in the idea of geometry again. More when we go back outside and track how fast I'm going on the bike. I hope we get some nice weather before then. I don't think this is... No.
It's raining.
Well, hopefully not for the next like 4 weeks. I'm hoping that...
There's going to be a 30% chance of rain all day.
30% chance of rain all day?
Yeah.
What does that mean?
Every hour there's a 30% chance.
What does that mean?
Every hour there's
What does that mean? What does a 30% chance mean?
I don't know.
But yet we believe it and we rely on it.
No, there's 30% chance that it will rain in your area, but it's going to rain.
What does a 30% chance mean?
The rain increases.
See, if you say it will rain, that sounds like a 100% chance.
Actually, it's more likely. Can we explain that? I don't wonder what
You kind of did explain it already. I mean, you explained it with the prisoner problem, which I stuck some probability in you guys. We explained what these chances mean. In the prisoner problem, it was things like 81% chance and 75% chance and things like that. So applying that logic, what does it mean to have a 30% chance?
30% chance of rain that day?
Say that again, Matt. Say that again.
30% of Shoots County will see rain.
Okay, that's what the weathermen, half the weathermen I've talked to have said that exact statement. If you look at the entire area of Deschutes County, or whatever area you're talking about, if you're in Philadelphia, it's Philadelphia, if you're in San Fran, it's San Fran, and you draw, if you will, like a rectangle around that, 30% of that area will see rain. Now my question back to them is when? Like the entire time? Or is the 30% move? At which point they go, well, the models, and I'm like, okay, that's cool. If you don't know, just tell me you don't know. That's totally fine. So 30%, when I hear 30% chance, the first thing I thought of was what the other half of weathermen have told me in the past. What they've told me is, when you measure the atmospheric pressure, when you measure the temperature, when you look at the time of year it's in, and you have all these different variables, all of which add one variable to the equation, when they are like they are right now, in the past it has rained 30% of the time. That's what half the weathermen told me, besides the other half that told me what you told me, Matt. So in other words, when the pressure is what it feels like right now, when it's the humidity is what it is right now, and I know rain is 100% humidity, but before it rains, when the wind is what it is right now, out of the direction that it's coming at right now, during the time of year that it is right now, there's all these variables, all these variables, all these variables. Historically, it has rained in 30% of those instances. That is the prisoner problem. What does it mean to have a 75% chance of living? It means if you put 100 people in a row and make them all use the strategy that you guys outlined on your quiz, how many out of those 100 are going to live on average? That's what a 75% chance means. Over time, you're going to see those results 75% of the time. It's very easy to say there's a 75% chance, but nobody ever explains to you, what does that actually mean? What does it mean to have a 75% chance? It means over time, you get the desired results 75% of the time. So out of every 100 trials, you get 75 successes on average. Over 100 trials, you get 30 days where it's going to rain with these given atmospheric conditions. That's what half the weather people say. The other half give me the geometric argument, which I like too. But the question is, I don't know when. Does that mean the entire time, like the entire time, essentially 30% of the shoots is getting rained on, but it's like moving around? Possibly. Possibly. I mean, maybe. I don't know. But if it's sitting still, it's like, isn't that 100%? And the weathermen start going like, I don't know, the computer tells me, it's cool, it's totally fine. I got no problem with that, just I want to make sure I understand what it is. And that's why students get frustrated when I ask them, what does a 30% chance mean? What does a 40% chance mean? When you flip a coin, what's the chance you get hits? Why? Right, you only have 2 choices. But 50% guarantees what? I mean, you have 2 choices on a weighted coin too, but it's not 50-50. If I'm crossing a street, I'm either going to get hit by a car or I'm not. Right? I mean, you're in Oregon. You're anywhere. You cross the street, you're going to get hit. Does that mean there's a 50-50 shot of getting hit by a car every time I cross the street? Only 2 outcomes, right? So what's the difference between, my God, I hope not, right? So what's the difference between walking out into the street and a coin? I love what Aaron's saying here. This is perfect. What's the difference, Brittany?
There's outside variables that are affecting it.
But even so, if I've accounted for those, there's still a number that's attached to it. I see what you're saying, there's outside variables. There's also outside variables that affect the coin flip, like gravity and physics and friction and all those things.
But like if you're walking out when the crosswalk's on, or when the car's coming, or when it's busy time, or when it's not busy
But
time.
even after you've applied all those, it's still not 50-50. If you had to say, what's the chance of getting hit in a crosswalk? If you had to give, even after you've adjusted for all that, if you had to assign a probability for that, what would you say the likelihood is of getting hit in a crosswalk? Say on College Way. Let's make it simple. The crosswalk on College Way, right outside of Mazama, which is very popular. What do you think the chance is of being struck? Let's say it's bright daylight, no parked cars on the side of the road. And this is pretty fictitious because there are always parked cars there. But let's make it easy. Parked cars on the side of the road, no parked cars on the side of the road, clear as a bell. You're getting ready to cross, you stop, you look, and then you go. What's the chance? What day are we going to be? Wednesday, high noon.
So you're saying you had 100 people do that.
I'm asking what the chance of you getting hit is first. 100% chance of being hit?
Yes.
Something negative.
What about the events? Is there anything going on?
Let's make it simple. No, nothing outside of normal class time. Give me a number
110%.
chance of not getting hit.
of not getting hit.
Right.
So let's make it, since it's, you know it's not a 100% chance, because some people do get hit, correct?
10%.
Yeah, like a 10%.
Yeah, but
10% chance of getting hit?
You're saying there's no cars, it's a sunny day. you
No cars
looked out,
parked.
you-
No
yeah.
cars parked, so
It's a
perfect
sunny day,
visibility.
You looked outside both
Yeah,
ways,
yes.
blah, blah, blah.
But you can still get hit. I've done that and almost gotten hit in that crosswalk. I see the car coming at me. I'm like, I look over, I see them like they see me. It's the law anyway. I step out, and they screech to a stop. Now, I cross that crosswalk dozens of times a day very often. So the chance of me almost getting hit goes up, because the chance of never getting hit goes down.
How about 3%?
It's kind of like going to the store and 3%. So what does that mean? If there's a 3% chance of getting hit, or almost hit in my case, thank goodness. Out of every 100 times I cross the road, I'm going to get hit or almost get hit roughly 3 times out of the 100 on average. You see how that's different than a coin flip? A coin flip, the heads and the tails are assumed to be equally likely. There's 2 outcomes, just like there is crossing the road. You either get hit or you don't get hit, or you either get hit or almost get hit and you don't get hit. But they're not equally likely anymore. This is why probability is fairly intuitive to people, but explaining probability to somebody else is trickier. It's trickier, having to know what it means to have. Whenever I hear a 30% chance of rain, I just tell myself it probably won't rain that much. When I hear a 70% chance of rain, I say it's probably going to rain on me on my bike ride at some point today. I mean, those numbers, to me, are almost meaningless. If it's below 50% or above 50%, that's what I pay attention to. Because honestly, the computer models are spitting out something that nobody understands anyway, apparently. All the weather people I've asked really don't fully understand what's coming out. And that's okay. That's okay, as long as you can apply a meaning to them. Does that make sense? Does that piss anybody off? I hope not. I hope not. Okay, maybe not. Maybe. Maybe you're still... Wow. It's a hell of carbonation. That was nice. Please, Ryan, yes?
I can safely say that 3 out of however many people crossed that crosswalk in the last year.
You could safely say...
3. The odds are 3 out of however many people crossed that crosswalk in the last year.
Have been hit.
How many people are on the crosswalk?
Could be millions.
Well, I was just using my own experiences as a number for that one.
But I know for a fact that 3 people have been hit.
Oh, I see what, I'm sorry, I see what you're saying, Ryan. I was missing the point. So you know that 3 people have been hit. So then we can apply, now that's just what Ryan knows about the 3 people. Okay, so if we use that as the success rate, which I'm using success in quotes because it's what we're interested in, is measuring this probability. 3 out of X, wherever X is. X might be 10,000, X might be 100,000. It's pretty low. And this is my point. It should be pretty low. It shouldn't be 50-50. Because if it was 3 out of 6, Then we start worrying about what the hell's going on if every other person is getting hit in the crosswalk. Which is when things start happening, and it doesn't take even 50-50. They start putting those flashing things like at Pilot Butte and the one down on 97, they start putting those in when even one accident happens. Because even with one accident happening, the chance of one accident is it's a tragedy. If somebody gets hit, I think someone was actually killed on 97, I believe, trying to cross 97. I think eventually the school will either close College Way to drive it. I think that's in the master plan for 20 years. Or put some kind of a habit trail above College Way that gets people off the road and cross up in the air and drop down. Well, I mean, it's not that busy of a road, but honestly, I'm fairly convinced that COCC students' cars will not start after their classes unless their cell phone's in their ear or being texted upon. I'm fairly certain of this as a bike commuter. Because every time I've had a near hit at COCC from a student in a car, it's because their head is in their phone. Either like this, or my favorite, like this, on the wheel, like this. Please don't do that. I mean, in general, but for those of us that are completely exposed on a bicycle, it's that much worse. And then when I pound on the hood, they look at me like I'm the one that's the idiot. Yeah.
First day.
I am the idiot, I know.
First day of class.
Yes.
Coming up the hill.
Yes.
Twice.
Yeah.
Near miss for me.
Yeah,
In a crosswalk.
that-
In a crosswalk, and people doing this.
Yes.
While they're going around those.
Yes. That is slightly terrifying. And in a car, it's bad enough. Then take the protective shell of the car away and put yourself on a bicycle that weighs 1/10 of what I weigh, and you realize that it's that much worse. And I mean, I've never been hit. Am I lying to you? No, I've never been hit in bed. I've been cut off a number of times. I've only never been hit on the East Coast. And people generally don't realize they're even doing anything wrong. The guy that hit me on the East Coast, I dove through his window and grabbed him by the shirt. He's like, what? And I realized he didn't even see me. He clipped me and kept going, didn't even know I was there. So we're already in your blind spot. We're already almost in, I mean, think about motorcycles. They're not seen, correct? A bike is like a really skinny motorcycle with less protective wear. I mean, I got bright blinky things all over the place. But still, all that does is increases the likelihood that you see me. But if your eyes are down on a phone, you're not going to see me at all.
But even in a crosswalk, it's like, okay, well, we know here we're going to keep everyone who we're going to hit in this little walkway. Yeah. You know, and then they don't want to hurry up.
There's a lot of assumptions that have to be met in order for it to work. And even if one or two of those don't meet, sometimes it's disastrous results. Yeah.
Like just the other week, we were on a crosswalk. There was a guy this far away.
Yes.
And he was looking both ways, and we were crossing.
Yes.
And he was like this close to hitting us.
Yes. People can look. This is from 20 years of bike commuting. 20 years of bike commuting. People can look directly at you. Even if you're in a car, if you're walking, if you're biking, they can look directly at you, and you're like, okay, they saw me. They might not have. They might be looking just in your general direction, and they have no idea that you're even there. So just because somebody makes eye contact with you, whether in your car, whether you're biking, whether you're walking, don't assume they saw you. Don't assume they saw you. This is one of the reasons I have 2,000 lumens of light on my head and my handlebar. Because if I can shine that really quickly in a car, and if I see the driver go like that and then look up, I got his attention. He might not hit me now. Unless I blinded him, in which case he might. Yeah, so it's possible.
No, I was going to say the crosswalk downtown, if you go...
There's many of them.
Yes.
Which one?
Wall Street.
Which one on Wall?
Right, Powell's, where it's like the Drake, and then you have Powell's.
Oh yeah.
Ooh,
The
yeah.
Starbucks area. Like literally, I was crossing...
Franklin?
Yeah.
Franklin.
Yeah, okay,
kinda like
gotcha.
going on
I was thinking of the
Franklin.
next one north, but
No,
Franklin.
but
Okay.
either one, even
Uh-huh.
because you have this road going that way, you have the 3 lanes,
Yes.
and then people want to turn that way.
Yes.
I was walking, and this guy was just coming, and just like right there. It was walking, and it's like stopped.
The trick with that
Like-
one, no, yes, the trick with that one is
Crazy.
pedestrians have a bit fewer rights on that one. Do you know why?
Because it gives you 12 seconds.
Because
leeway
it's signed.
after
It's a
stopped.
signed crosswalk. It's at an intersection light. That's different than the one on College Way. College Way, essentially, the idea is, state of Oregon law, you put your foot in that crosswalk. If there's a pedestrian waiting to cross the crosswalk, cars have to stop for you. But at that light, they don't unless you have the hand. You can't walk. In other
But
words, if the
there's
light's
still,
green,
like, the 12 seconds when you're
oh,
crossing.
absolutely. I'm not saying.
seconds.
I'm not saying. But you can't walk anytime you want to in that lane.
Right.
If it's got a big red hand and the light's green, that's
Okay.
like rushing. Then it's a 50-50 chance of getting hit.
Yes.
Then it goes to a quote. Am I gonna make it? Oh, I'm gonna stay right here until I think. So that changes a little bit. But then cars have to be cognizant of that. It happens in cities all the time. Anyway, the point being is that there are likelihoods attached to all of these things. Whether it's weather, whether it's crosswalks, whether it's coin flips. I want to kind of steer the class towards that for the next few weeks. And healthcare is a fun way of getting into that. This is what? What? I'm sorry.
It's a very talked about
Oh, it is!
thing right now.
It is very talked about. It's also talked about unintelligently quite often. I mean, that's what I want to talk about today, is I want to talk about it intelligently. I want to leave politics out of it.
Oh,
I mean,
awesome.
well, you have to. I mean, if you let politics run the conversation, we're never going to get anywhere.
Oh, yes.
You know, you've heard the breakdown of the word politic, right? What does poly mean when you apply poly to a multiple, right? What is a tick? A blood-sucking creature? So what is politics? So anyway, we're going to leave politics out. Just look at numbers. Let's just look at numbers. I mean, that's